Hello everyone, and welcome to this section of the course that focuses on just general machine learning. And in this particular lecture, we're going to try to get an understanding of what is machine learning. So before we jump into neural networks, TensorFlow, the Keras API, etc., it's a good idea to understand a few fundamental general concepts regarding machine learning. So in this section, we're going to cover some important theory and concepts surrounding machine learning. So we'll be covering things like, in this lecture, what is machine learning, as well as answering the question, what is deep learning? Then we'll talk about in future lectures the differences between supervised and unsupervised learning, the actual supervised learning process, and then how do we actually evaluate performance? And how do we evaluate performance for different tasks? If we're performing a regression task, like trying to predict the price of a new house on the market, or performing a classification task, such as trying to predict whether we have an image of a cat or a dog. There's different ways to evaluate how well our actual machine learning models are performing or doing. So we need to take that into account. And then we'll also discuss things like overfitting. So all of these concepts can apply to just general machine learning algorithms. So it's important that we have a general understanding over a lot of these things before diving into things like neural networks and deep learning. So let's first briefly discuss what is machine learning. Machine learning is a method of data analysis that automates analytical model building. Using algorithms that iteratively learn from the data, machine learning allows computers to find hidden insights without being explicitly programmed where to look. So typically, a lot of times when we're trying to program something using Python, for instance, we have to tell the program what to do in each case, maybe with an if statement or an if-else statement. However, with machine learning, what we do is we follow a general process and then allow the machine learning algorithm to figure out what the best approach is dependent on the data. So really, it ends up learning from the data, and that is what automates the model building. So what is machine learning used for? Well, machine learning is used in a wide variety of topics and use cases. Everything from fraud detection to web search results to credit scoring. So if you're ever applying for a mortgage, there's machine learning happening behind the scenes to see if you're creditworthy. Or maybe you're traveling abroad and you use your credit card and you get a call indicating a possible fraud on your credit card. That's also machine learning attempting to detect fraudulent use cases. Then there's things like recommendation engines. So if you're shopping on something like Amazon.com or even viewing some online streaming video service and it's recommending new videos or new movies or new TV shows to you, machine learning is used for that as well. And things like email spam filtering, so the emails that actually go into your spam folder, that's using natural language processing to figure out what is the actual spam email, and then things like pattern and image recognition. Now there's certain use cases where the only possible approach is to use deep learning. So keep that in mind later on in the course, especially during things like convolutional neural networks for image analysis. We'll be learning techniques where the only way to actually conquer this task, so to speak, is by using the capabilities of deep learning and neural networks. So what are these neural networks? We're going to go into a lot more detail about how neural networks are constructed in the next section of the course, but for the basics, neural networks are a way of modeling biological neuron systems mathematically. And these networks can then be used to solve tasks that many other types of algorithms can't. So for example, that image classification, it's really hard for other machine learning algorithms to perform well on things like image classification. And this is the kind of task where neural networks perform very well. So deep learning simply refers to neural networks with more than one hidden layer. Now, there are many different types of machine learning tasks, and in the next section of the course, we're really going to be focusing on two specific types of machine learning tasks, and those are supervised learning tasks and then unsupervised learning tasks. So we're going to cover supervised learning and then briefly talk about unsupervised learning. In the next section of the course, when we talk about things like classification and regression, those will fall under supervised learning. So it's important to understand the distinctions between these two various topics. And then as a final note, sometimes students get confused between machine learning, neural networks, and deep learning and what the differences are between them. As a quick review, machine learning, those are just a general terms for those automated analytical models. Neural networks is actually a specific type of machine learning architecture or algorithm that's specifically modeled after biological neurons. And then deep learning, put simply, is really just a neural network with more than one hidden layer. And we'll discuss what that means and what a hidden layer actually is in the artificial neural network section of the course coming up next. So let's go ahead and begin by learning about one of the most common machine learning tasks, which is supervised learning. I'll see you in the next lecture.